This website provides a really good demonstration to experiment with fully connected neural networks. First, we're going to look at a neural network that has one layer, that is one output layer. So this is a classification network, and what we would like to do is classify 2D points. That means we have a bunch of samples. Every sample is a 2D point, and there are two classes. There's the blue class, so all these points here belong to the blue class, and there's the yellow class. All the points here belong to the yellow class. The task of the classifier now is to classify each point as either belonging to the blue class or the yellow class, and the coloring of the points shows the ground truth, and the background color, so for example blue here, yellow here, that shows the prediction of the classifier. So at the moment the classifier believes that the blue points would be in this top left corner, and the yellow points would be in this bottom right corner predominantly, and this white line that you see here is the decision boundary where the classifier is unsure. Needless to say that the classifier is in a pretty bad state now. However, this is simply the initialization. This is a random initialization. You could also think that the more blue it is, the more certain the classifier is that this is a region belonging to blue points, and the darker yellow it is, the more certain the classifier is that this is a region belonging to yellow points. Now what we can do is we can start the optimization. So we do optimization one step at a time for now, and what we will see is that the decision boundary will improve. So we do one step. What we see is after one step, the classification is already completely correct. All the blue points are on the blue side of the decision boundary, and all the yellow points are on the yellow side of the decision boundary. However, the decision boundary is not optimal in the sense that it could be a bit more nicely separating the yellow and the blue points. If you're thinking that later on there's going to be some other test data, some unseen data, we would like the classifier to generalize as good as possible, and for that a nicer decision boundary would be good. So we're not going to go into details of what makes a nice boundary or not, but let's just look what happens here. All right, so we see that the boundary becomes nicer and nicer for a particular definition of nice. You can also let it run automatically, and this should show that it still kind of slightly changes maybe. Okay. So this is the simple case. Let's look at the more complicated distribution, and there are 4 distributions to play with. This is what we could call the XOR distribution. And this goes back to this famous insight that the XOR function cannot be correctly classified by a one-layer linear classifier. What we start out with is, let's take some random initialization, maybe this one, and now we can again try to optimize and find the best possible decision boundary. And just thinking about this yourself, you could put this linear decision boundary wherever you like, and there's not going to be any way that you can separate the yellow points from the blue points. Nevertheless, we can observe the network, how it tries to find this decision boundary. I'm just going to run, and it's going to continuously perform many steps of optimization. All right. So it's kind of confused and it's kind of uncertain, so it goes to a state where it doesn't put a lot of certainty anywhere, but it's still misclassifying half the points. So let's look at these blue points in the top right corner here. They would all be misclassified. They would all be misclassified as belonging to the yellow class. These blue points here would be correctly classified, And then we look at these quadrants of yellow points. This one here, half of them would be classified correctly. So this half here maybe is correct, and this half incorrectly. And the same for this quadrant here. We would have half of them classified correctly and half incorrectly. Needless to say that more complicated distributions, such as this spiral, are also not going to work. Let's just try this out. Also, what you can see here is a test loss and a training loss. This you can observe while the optimization runs. So let's start with a new initialization. So we see that the losses are around 0.796, 0.784, and then we run the optimization again. So just try to observe how these numbers change. All right. So it goes from 0.7 something to 0.4 something. So there is a decrease in the loss function. We can also now experiment with the activation function and set it to ReLU, sigmoid, linear, but let's just maybe put it at sigmoid. Okay, and now we add more layers. Let's add another hidden layer with 2 neurons. And let's go back to the first set. So this should be simple, and we still hope that by running the neural network again now, this will still be simple to classify correctly. All right, let's run. Okay, no problem, works great. The next challenge is this XOR type distribution. Let's see different initializations, so you can play with different random initializations. Let's just see if it works. Okay, we can see that this is a bit better, but conceptually this is not working, because the proper decision boundaries should go along these x and y axis. But what you see here is that it tries to slice it in some sort of a funny way. It still works pretty well, but it's not really what you want. Maybe let's try another initialization and try again. Let's see if something better happens. Nope. Okay, so what you can do now is maybe add more neurons. Let's add 6 neurons and see if we can improve. All right, so while we don't have a split into quadrants, this is much more similar to what we would actually expect and how we would draw the decision boundaries as a human. And we can now again try to remove neurons and see how many neurons in this hidden layer are really necessary to obtain these type of decision boundaries. Now you can also add more layers and then maybe try to do one of these more complicated ones. I think the spiral is the most complicated one. So you can add more neurons. Maybe let's see what happens and how the decision boundary evolves. Okay, I guess that was quite a disappointing result. So I'm going to leave it at that, but I hope that you will find some time to play with this, trying to work with these different type of distributions and then see what is the effect of adding more layers, changing the activation function, And you can also look at the visualization of the individual neurons and try to play with these many hyperparameters.